this happens because polypropylene is not a totally inert material. In any case, it causes a granuloma and a fibrous reaction that is well known from any surgeon who's devoted also to the repair of abdominal wall. Everybody knows that polypropylene cannot be put in direct contact with Wittgenstein because of this granuloma reaction that is lifelong, that is continuous. And even if a lighter mesh can guide this process, preserving pores and avoiding stiffness, it still is something that happens. And you can see here how can these important fibrous reaction create problems. This is an erosion of a plug on a vase, on a deferens vase, and this is vascular invasion created by this fibrinosis ingrowth. Of course, these pictures have been made on heavyweight meshes, but polypropylene and human tissue, of course, is not the solution forever. Including partially reabsorbable threads in a mesh can in some way avoid part of these problems, even if granuloma reaction is not totally avoided. But this is done because there is the idea that the reabsorption process can lead and in some way circumscribe the fibrous reaction in the way that we want. It's like an indication of regeneration more than host tissue reaction. It is not totally true by an histopathological point of view, but this is the idea that came out observing the histopathological behavior of new lightweight meshes. So what happened now? That what we once believed were the ideal prosthetic endpoints, permanence, inertness, and rapid fixation, have now been substituted by small weight and large pore. What is the next step? The small weight, large pore mesh must be built in polypropylene, or there is something new, something better that we can think for the future. Well, polypropylene is polypropylene, and shrinkage is just the same. Lightweight, midweight, heavyweight, but shrinkage, reaction, is always the same. So industry is producing something new, not just for protecting meshes against viscera, not just for giving totally reabsorbable, but reabsorption in these cases means leading the reconstitution of native tissue along a path that is designed and helped by reabsorbable material. Of course, these reabsorbable material are not the best. Manufacturers provide us of a number of new devices, and the choice is it's up to you. I will not talk in favor of one or the other, but for concluding my presentation, I would like to give an indication about the possible future that we will see. At the moment we are here, we are still using for inguinal hernia inert, inactive, permanent materials, but history of abdominal wall reconstruction is giving us new advices. Bioactive materials can be part of our next future also in inguinal repair, even if this stairway to heaven of research sometimes is a stairway to cost for a hospital practitioner. But you see, if we can lead with a partially, temporarily scaffold the degradation of our prosthetic until we obtain a reconstruction, never going lower than this baseline that is a native fascia burst strength, we have found what can be a perfect bioimplant with no tissue that is totally different from what is human. Is this possible? Well, some new device now is providing us of scaffolds that are made from biological tissues that are leading the cellular migration, and then the vascularization, then the total reconstruction of a solid human tissue on this totally acellular and inactive biological scaffold. We have different proposals now that are already available with different characteristics. This is a double layer of Gore-Tex that is different in pore size and in structure, so giving on the external side the strength of the so-called tissue patch, and from the visceral side a large pore and thin layer of the same material. But there is some more. There is some more that is the derivation from porcine collagen or from porcine intestinal wall of this structure that are filled with collagen fibers. What is derm without cells, and it can mimic a perfect ideal scaffold for new cell to migrate and to create a new abdominal wall. Alloderm is the last and extremely costly production that is made from human donors, not cadavers, from human donors. Their possibility of resist to burst load is extremely high, totally comparable to new alloplastic materials. But future perspectives are not these. Future perspectives are the possibility of creating this scaffold by using nanotechnology. Nanotechnology is a new multidisciplinary science that can mimic the mechanism of nature in reconstructing what is perfect, and this engineer-designed scaffold using biomaterials can lead the regeneration of tissue in the direction and with the characteristic that we desire. This is the next frontier. Is not science fiction. These slides have been given to me by courtesy of an engineer who works in Turin. He's not a doctor. It's called Dr. Ciardelli. And he strongly believes that using this scaffold, we can reach not only our interesting goal of perfectly reconstruct the abdominal inguinal wall, but also whole organ regeneration as soon as we understand the mechanism that are governing at the nano dimension, the interaction in between macromolecules and cell by cell, in order to recreate an organized